This is your 3.6 Part 2 WebAssign. If you remember from Part 1, we went over your X and Y intercepts as well as your vertical and horizontal asymptotes. For your X-intercept, if you were finding that, you are plugging in 0 for Y and just working with your numerator. If you find your Y-intercept, plug in 0 for X. Anywhere you see an X, solve for Y. Those, remember, are ordered pairs. You have to give your answers as ordered pairs for those. For your vertical asymptote, take the denominator, set it equal to 0, solve for X. For your horizontal asymptote, compare the numerator's degree to the denominator's degree. If they are the same, take the leading coefficient from the numerator, put it over the leading coefficient of the denominator, and simplify. It's going to be y is equal to something. If the top degree is greater than the bottom degree, your horizontal asymptote is none. And then if your top degree is less than the bottom degree, it's automatically y is equal to 0. So, looking at the first question, we have r of x is equal to x squared plus 4x plus 5. Change that to be a minus 5 real quick. Over 3x squared plus 12x plus 12. So we're just going to change this to be a minus 5 up top. And it'll actually work out the right way. All right, so for your x-intercept to start with, you are going to work with just the numerator and set it equal to 0. So we have x squared plus 4x minus 5 is equal to 0. We can factor this out, find the factors of negative 5 that add up to be 4. We have negative 1, positive 5. So this factors to be x minus 1 times x plus 5 is equal to 0. If we set both of these equal to 0, we're going to have x minus 1 is equal to 0 and x plus 5 is equal to 0. So we move the 1 over and the x minus 1 is equal to 0 by adding it to both sides, and we get x is equal to 1. For the x plus 5 is equal to 0, we subtract the 5 over, and we have that x is equal to negative 5. So this gives us two ordered pairs, one that is the negative 5, 0, and the other that is 1, 0. For your y-intercept, you're going to take the entire expression, set it equal to y, and then plug in zeros anywhere you see an x. So it's going to give you y is equal to 0 squared plus 4 times 0 minus 5 all over 3 times 0 squared plus 12 times 0 plus 12. Anywhere you have that 0 squared or that something times 0, they cancel out. So that's just going to leave you with negative 5 over 12 for y. So that is the ordered pair, 0, comma, negative 5 over 12. Next, we are going to find our vertical asymptote. To find your vertical asymptote, you're going to take the denominator, which is the 3x squared plus 12x plus 12, and set it equal to 0 and solve. You can factor this by first factoring out the greatest common factor, which is 3. So that leaves us with 3 times x squared plus 4x plus 4 is equal to 0. That 4 has factors of 2 and 2 that add up to be 4. So this factors to be 3 times x plus 2 times x plus 2 is equal to 0. We're going to set each part equal to 0 and solve. So the 3 is equal to 0, the x plus 2 is equal to 0, and the x plus 2 is equal to 0. That 3 is not equal to 0, so cross it out, don't work with it. That x plus 2 is equal to 0, you see that twice, so if you want, you can cross one of them out and just work with the other one. So you're going to subtract the 2 from each side, and you get that x is equal to negative 2 for your vertical asymptote. Lastly, for this question, we're going to find the horizontal asymptote. To find your horizontal asymptote, you want to compare the numerator's degree with the denominator's degree. The degree from the top is 2. The degree from the bottom is 2. These two are equal to one another, so we're going to take the numerator's leading coefficient, put it over the denominator's leading coefficient. So your numerator's leading coefficient is 1. The denominators is 3. 1 over 3 cannot be simplified, so your horizontal asymptote is y is equal to 1/3. For our next example, we're given s of x is equal to 5x minus 15 over x minus 5 times x plus 1. For this one, to find your x-intercept, you're going to work with the numerator only. So you're going to have, here, let's do it, x-intercept 5x minus 15 is equal to 0. We're going to factor this by factoring out a 5. So this is going to be 5 times x minus 3 is equal to 0. We set each part equal to 0. So 5 is equal to 0. X minus 3 is equal to 0. And we solve them. Is 5 equal to 0? No. So you can cross that one out. The x minus 3 is equal to 0. Move your 3 over. Add it to both sides. You have that x is equal to 3. You could do that too. Oh, okay. That's fine. You get the same thing. Oh, yeah, for some reason with me, I'm like zoned into factoring before I do anything else. But yeah, you could have added the 15 over and then divided each side by 5. It's the same. You're gonna get the same thing. So because x is equal to 3, that gives you the ordered pair of 3, 0. For your y-intercept, you are going to take the function that's given to you, set it equal to y, and then plug in 0 for any x value. So that's going to give us 5 times 0 minus 15 over 0 minus 5 times 0 plus 1. So this just simplifies to be negative 15 over negative 5 times 1, which is negative 15 over negative 5. That simplifies to be y is equal to 3. So that's 0, 3. To find your vertical asymptote, you are going to take the denominator, which is the x minus 5 times x plus 1, set it equal to 0, and solve. This one's already factored for you. So the only thing you have to do is set that x minus 5 equal to 0, as well as that x plus 1 equal to 0. So we're going to move that 5 over by adding it to both sides. We get that x is equal to 5. Move the 1 over by subtracting it. That's x is equal to negative 1. So your two vertical asymptotes are at x is equal to negative 1, as well as at x is equal to 5. For your horizontal asymptote, you are going to look at the 2 degrees of the numerator and the denominator. If you FOILed out the x minus 5 times x plus 1 in the denominator, it would give you a power in your denominator of 2. So your numerator's degree is 1, your denominator's degree is 2. That 1 is less than 2, so automatically our horizontal asymptote is y is equal to 0. Lastly, for this one, we're going to find the wholes. By finding the wholes, we are going to factor the numerator and the denominator and see what would be the same or what it would cancel out. Whatever is the same or whatever's going to cancel out, you're going to set equal to 0 and solve for. So if we have 5x minus 15 over x minus 5 times x plus 1, and we factor that top, we're going to have 5 times x minus 3 over x minus 5 times x plus 1. There is nothing that is the same on both the top and the bottom. So your wholes, you don't have any. So you would just write none. For number 3, we have the function s of x is equal to 2x plus 4 over x squared plus x minus 2. If we first find your x-intercept, you're going to have the 2x minus 4 is equal to 0. If you want to move the 4 over first, we can do that by adding it to both sides. And then you have 2x is equal to 4. And then you divide each side by the 2. So you get that x is equal to 2. So that's the ordered pair 2, 0. For your y-intercept, so if this was a positive, not a negative, you would subtract the 4 over instead of add it. So then you would have 2x is equal to negative 4. Divide each side by the 2, and that's negative 2. So your ordered pair for your x-intercept is just negative 2, 0. For your y-intercept, we're going to take the 2 times x, which is going to become 2 times 0, plus 4 over x squared, so 0 squared, plus x, which is 0, minus 2, set it equal to y. So this is going to be 0 plus 4 is just 4 over negative 2. 4 divided by negative 2 is negative 2. So that is your ordered pair of 0, negative 2. For your vertical asymptote, you are going to take the denominator, so that x squared plus x minus 2, set it equal to 0, and solve. Your factors of negative 2 that add up to be positive 1 are 2 and negative 1. So this factors to be x plus 2 times x minus 1 is equal to 0. We set each part equal to 0, and we solve. For the x plus 2 is equal to 0, subtract your 2 over. You have that x is equal to negative 2. For the x minus 1 is equal to 0, add your 1 over. You have that x is equal to 1. So that gives you the 2 vertical asymptotes of x is equal to negative 2 and x is equal to 1. For your horizontal asymptote, you are going to compare your numerator's degree with your denominator's degree. The numerator's degree is 1. The denominator's degree is 2. 1 is less than 2, so automatically we have y is equal to 0. Lastly, you're going to find your wholes. If you take the top, which is 2x plus 4, and the bottom, which is x squared plus x minus 2, and you factor both of them, you're going to have 2 times x plus 2 over x plus 2 times x minus 1. The top and the bottom both have the x plus 2. So take that x plus 2, set it equal to 0, and solve. Move your 2 over, subtract it from each side, and you get a whole at x is equal to negative 2. For number 4, you are given the function r of x is equal to 2x squared plus 10x minus 12 over x squared plus x minus 6. So we're going to find your x-intercepts first. So x-intercepts, you're going to take the numerator, which is the 2x squared plus 10x minus 12, set it equal to 0, and solve. You have a greatest common factor of 2, so factor out the 2 first. That's going to give you 2 times x squared plus 5x minus 6 is equal to 0. Your factors of negative 6 that add up to be 5 are negative 1, positive 6. So this factors to be 2 times x minus 1 times x plus 6 is equal to 0. Oops. From here, you're going to set the 2 equal to 0, the x minus 1 is equal to 0, and the x plus 6 is equal to 0. And you're going to solve them all. So the 2 is equal to 0, false statement, cross it out, don't work with it. X minus 1 is equal to 0, add your 1 over. You have that x is equal to 1. For the x plus 6 is equal to 0, subtract 6 from each side. You have that x is equal to negative 6. So your two x-intercepts are negative 6, 0, and 1, 0. To find your y-intercept, you're going to plug in 0 anywhere you have an x and solve. So you're going to have y is equal to 2 times 0 squared plus 10 times 0 minus 12 all over 0 squared plus 0 minus 6. The 2 times 0 squared and the 10 times 0 are both 0. So up top, you just have that negative 12. On the bottom, the 0 squared and the plus 0 are both 0. So you just have the negative 6. Negative 12 divided by negative 6 is 2. So that's the ordered pair, 0, 2. Next, we will find your vertical asymptote. So we're going to take the bottom, which is the x squared plus x minus 6, set it equal to 0, and solve. We said that x squared minus x minus 6, or no, sorry, we didn't do that one. We did the top. The factors of that negative 6 that add up to positive 1 are 3 and negative 2. So this factors to be x plus 3 times x minus 2 is equal to 0. We set them both equal to 0 and we solve. We're going to move the 3 over by subtracting it from each side, so you get that x is equal to negative 3. Add the 2 over by adding it to both sides, you get that x is equal to 2. So your two vertical asymptotes for this one are x is equal to negative 3 and x is equal to 2. Next, we'll find your horizontal asymptotes. So we're going to compare the numerator's degree with the denominator's degree. The degree up top is 2. The degree on the bottom is 2. These two are equal to one another, so we're going to do y is equal to our numerator's leading coefficient over our denominator's leading coefficient. Up top, your coefficient is 2. On the bottom, your coefficient is 1. So that's just y is equal to 2. Lastly, we're going to find your holes. So you're going to start with what's given to you, which is the 2x squared plus 10x minus 12 over x squared plus x minus 6, and you're going to factor both the numerator and the denominator. When we did the y-intercept, we factored that numerator to be 2 times x minus 1 times x plus 6. When we did the vertical asymptote, we factored the denominator to be x plus 3 times x minus 2. There is nothing that is the same on both the top and the bottom of this function when they are both factored out. So your holes are none. For number 5, we're given the function r of x is equal to 3x squared plus 3x over x squared minus 2x minus 3. We're going to first find your x-intercept. So we're going to take the 3x squared plus 3x and set it equal to 0. We can factor out the greatest common factor of this, which is 3x, and that's going to give us 3x times x plus 1 is equal to 0. If we set each part equal to 0, we have 3x is equal to 0, and x plus 1 is equal to 0. 3x is equal to 0, divide the 3 on each side, so that gives you x is equal to 0. For the x plus 1 is equal to 0, subtract your 1 over, you have that x is equal to negative 1. So two x-intercepts here, one that is 0, 0, and one that is negative 1, 0. For your y-intercepts, you are going to take that function, set it equal to y, plug in a 0 anywhere you see an x. So that's going to give you 3 times 0 squared plus 3 times 0 all over 0 squared minus 2 times 0 minus 3. This simplifies to be 0 over negative 3. And we said when we did part 1 that 0 over anything is 0. So your y-intercept is the ordered pair 0, 0. To find your vertical asymptote, you are going to take the denominator. So that x squared minus 2x minus 3, set it equal to 0, and solve. Your factors of -3 that add up to be -2 are -3, +1. So this factor is to be x minus 3 times x plus 1 is equal to 0. We set them both equal to 0 and solve. For the x minus 3 is equal to 0, add your 3 over. You get that x is 3. For the x plus 1 is equal to 0, subtract your 1 over. You have x is equal to -1. So your two vertical asymptotes are at x is equal to -1 and x is equal to 3. For your horizontal asymptote, you're going to compare the numerator's degree with the denominator's degree. The degree from the numerator is 2. The degree from the denominator is 2. These two 2's are equal to one another. So we're going to take the numerator's leading coefficient, put it over the denominator's leading coefficient, which gives us 3 over 1, which simplifies to just be 3. So that's y is equal to 3. Lastly, we want to find the wholes. So we're going to take the numerator, which is 3x squared plus 3x, keep it over the denominator, which is x squared minus 2x minus 3, and factor both the top and the bottom. When we did the x-intercept, we factored the top to be 3x times x plus 1. When we did the bottom, we factored the bottom to be x minus 3 times x plus 1. You want to look for what's the same in both the top and the bottom. That x plus 1 is the same on both the top and the bottom. So we're going to take that x plus 1, set it equal to 0, and solve. We're going to move the 1 over by subtracting it from each side, and you get that x is equal to -1. For number 6, we are given r of x is equal to x squared minus 3x minus 28 over x. And we're asked to find the slant asymptote and the vertical asymptote. When you find your slant asymptote, you need to be considerate of your horizontal asymptote as well. Because your slant asymptote, your horizontal asymptote, vertical asymptote will never be the same. So if you find your slant asymptote, you are just dividing the numerator by the denominator. So for your slant asymptote, you are going to take that denominator, which is x, put it on the outside. Then you have x squared minus 3x minus 28, put it on the inside of your division house. You want to ask yourself, x times what is x squared? That's x. So put that up top. Multiply it. You have x squared. Subtract the 2. That gives you 0. So you move down that -3x. You ask yourself, that x times what is -3x? That's -3. So that's -3x. You subtract. So those cancel. You drop down the -28, and that is your remainder. You do not need your remainder for this. It is just the x minus 3 that you are going to keep for that slant asymptote. And you set that equal to y, and then you're done. For your vertical asymptote, again, you want to take the denominator, set it equal to 0. So that's x is equal to 0. If you were able to, or if you were told to find your horizontal asymptote, remember with that, you would compare your numerator's degree with your denominator's degree. And then you would have 2 to 1. The 2 is greater than 1, so automatically if your numerator's degree is greater than the denominator's degree, it's y is equal, or sorry, it's none. For your last question, you are given r of x is equal to x cubed minus 9x over 2x squared plus x minus 10. You're going to use your long division in order to find your slant asymptote. You're going to have the bottom on the outside, the top on the inside. So this is going to give you 2x squared plus x minus 10 on the outside. The inside, you're going to have x cubed plus 0x squared minus 9x plus 0. Remember, if you're missing a so-called place value with your powers, you plug in that plus 0 times x to the power of whatever. First thing that you're going to start with, the 2x squared times what is x cubed? In order to get rid of the 2, you'd have to multiply it by 1/2. You also need an x to make that x squared and x cubed. So this 1/2 times 2x squared is going to give you x cubed. The 1/2 times x is just 1/2 x squared. And the 1/2 x times -10 is -5x. We are going to subtract these or add the opposites. The x cubes cancel. That 0x squared minus 1/2 x squared is -1/2 x squared. -9x plus 5x is -4x. And we bring down that 0 to represent that place value. From here, you want to turn that 2x squared into -1/2 x squared. If we multiply it by a -1/4, this is going to give us -1/2 x squared minus 1/4 x plus 10/4 is 5/2. We are going to subtract or add the opposites. The -1/2 x squared plus 1/2 x squared cancels out. -4x plus 1/4 x is going to be a -3 3/4 x. And then 0 minus 5/2 is -5/2. That is your remainder since you have nothing else to bring down. So you are taking this 1/2 x minus 1/4, and you're setting it equal to y, and that is going to be your slant asymptote. To find your vertical asymptotes, you are going to take the denominator, which is the 2x squared, plus x minus 10, set it equal to 0. You don't have a greatest common factor that you can factor out, so multiply your a and your c. 2 times -10 is -20. You want the factors of -20 that add up to be +1. That's going to be 5 and -4. So this gets rewritten as 2x squared plus 5x minus 4x minus 10 is equal to 0. You're going to factor by grouping from here. Factor out an x from the first. Factor out a -2 from the second set of parentheses. That leaves you with x times 2x plus 5 minus 2 times 2x plus 5 is equal to 0. Your two sets of parentheses are the same, so this gives you 2x plus 5 times x minus 2 is equal to 0. We set them both equal to 0, and we solve. For the 2x plus 5 is equal to 0, subtract your 5 from each side. You have 2x is equal to -5. Then divide each side by the 2. You have that x is equal to -5/2. For the x minus 2 is equal to 0, add your 2 over, and you have that x is equal to +2. So your vertical asymptotes are x is equal to -5/2 and x is equal to 2. It doesn't ask you for them, but if it did ask you for your horizontal asymptotes, your numerator's degree is 3, your denominator's degree is 2. 3 is greater than 2, so automatically we have what for a horizontal asymptote? None.